that I'll talk about. Yeah, the main change is that it cannot be considered a final assessment. So my the first that I heard of this news, it was described as a traditional final exam, right? That there will be no traditional final exam. So I'm on YouTube now, so I'm gonna actually just write some of this down. So okay, so what we had originally, and what I had originally called it, was a final assessment, right? And I originally gave us two options, right? We had a traditional final exam, and I mean that's traditional as in like you're a final exam, right? I mean it wasn't actually that traditional in the fact in that it would be done online, which is not traditional, but I think you understand what I'm trying to say. That we had the idea of a final exam, and then we had a final project. Okay, and these two things, this was our final assessment. So you could choose between one of those. And then sometime around the middle of last week, I learned that this year there are to be no traditional final exams. So I interpreted that to mean there are to be no traditional final exams, and that instead everyone will be doing a final project. So I kind of told a few people that, some colleagues, yeah, I'm going to do a final project. And then I'm glad that I did tell them, because then a few other people started looking into it. And then I learned later, I learned on Friday actually, that there is actually going to be no final assessment at all. So there's no final assessment. So that kind of makes you think, okay, well, what about the final project? Okay, so I feel torn in a lot of different ways. On the one hand, I totally understand where this is coming from, right? This the cancellation of final assessments, because this year is probably the weirdest year, certainly of this century, in terms of how education is working, and pretty much everything else, right? The whole world is turned upside down right now. We're all trying to figure out what this means. So I can kind of see why the idea of a final assessment doesn't make any sense, right? Yeah, what's the point? Because this year's grades are not the best representation of what you've learned this year, right? Especially since the lowest grade that you can get is what it was on March 23rd. So what is even the point of a final exam? So I looked into it a little bit more, and here's the thing about the final project that is just really important to me. And the reason I really want us to do this is because the way I structured this class is through just units, right? Like we did, and that's just because we followed the textbook very closely. So we didn't really get a good opportunity to look at the connections between these topics. And that's kind of where the final project, that's what I really liked about the final project. So usually in a final project, or even on a final exam as well, like a traditional final exam, it's an opportunity for you to sort of synthesize everything together and put it all together into one, right? Like when you study for a final exam, you really get to know the topics really well, right? That's the whole point of a final exam. The point of the final exam, it's in a lot of ways is not even really about the exam, it's about the studying of the exam. Like that's the important part, is the actual studying and actually really putting it all together. And I thought that the final project was a really good replacement for that. So I really want us to do this project. It's really important to me that we do this project, but we can't have a final assessment. So the final project is no longer a final assessment. Okay. So this is not going to be like in the category of like final exam. Like, it's not going to be worth like 30% of your grade or something like that. The project is now an assignment. Okay, and you might be saying, okay, Mr. Bennett, that's like the cheesiest loophole I've ever heard. Like we're not supposed to be doing a final project, and here you are, you're making us do a final project. You're just calling it an assignment. Well, in some ways, yeah, that's kind of true. But there's a key difference. Two key differences. So what's the difference between a final assessment and an assignment, other than the word? Well, I'm going to change it up a little bit. So first of all, so the assignment is worth less, not worthless, worth less than a final assessment. Okay? So this will be worth just as much as an assignment. So I hope that takes a little bit of the pressure off. Also, this is the main thing. And if there's one thing you can take home from this, is that the size of the project will be smaller. Is now smaller. Okay, and the way we're going to do that is we started off with 4 topics. Yep. Oh, I'm not alive. Oops. Yeah, here you go. Now you can see my screen. YouTube can see my screen. But yeah, I've been writing this stuff down. But you've been able to hear me. I pretty much just been writing what I've been saying. But yeah, no, but you can see me now though. Great. Okay. Yeah. So what I was saying is that I mean, and you can see kind of the diagram and the progression of our little conversation here. But we're going from 4 topics to 2 topics. Okay, so now what our project is, it is not to explore 4 topics and the connections between them. We are just going to be doing 2 topics. Okay, so I'm cutting the project in half. I'm really hoping that you didn't invest too much time already in investigating 4 topics. If you have, just consider it like you've done extra work and you're that much closer to being finished. So just like if you've already done stuff on 4 topics, narrow it down to the 2 topics that are the most similar, or the ones that you can find the most connections with. Just to give you an idea of what you can do to explore the connections between topics, and I've given this idea to a few students already, is to just try to find a real world problem that takes 2 of our topics. This is probably the 10th time I've spelled topics, T-O-P-I-S. I don't know why, but it's just my brain that's where it is today. So find a real world problem that takes 2 of our topics to solve. Okay, so maybe like you need trigonometry to like measure the distance from this to this, and maybe you can also use like radicals, because the solution that you get is some kind of like square root or something like that. So the scope of the project is much smaller. Now keep in mind that, and everyone keeps asking, what about the topic map? Yes, we are still doing it. We're still doing the topic map. Doing it. Okay. So the topic map, I know that that a lot of you are probably a little confused about the topic map, and I only say that because I get a lot of questions about it, especially in my other classes. I'm not getting a lot of questions from this class, but some of my other classes, they're a little confused about the topic map. it does not need to be super intense. Like, I think that the topic map, if you really just sit down with it and look at your textbook and look at our notes and look at these videos, you should be able to do this in maybe half an hour to an hour. Like, it does not need to be super intense. An example. So, like, here's 3 things. Here's 3 topics. I'm just gonna do them. This is all the stuff that we've done in the past like week. Okay. Sine law, cosine law. Well, actually, we're doing the cosine law today. We haven't done it yet. But you can tell me a little about the sine law. It solves triangles. Same with the cosine law. Solves triangles. And then the connection between them is that it is a formula. They are both a formula that solve triangles. Okay, and then you could do radicals. Radicals, right? So the connection between the sine law and radicals is that often the sine of a number is a radical. Okay, like it does not need to. Oh, and that should be the connection, by the way. So it does not need to be like super intense. Like just a quick, brief connection between 10 different topics. They don't have to be like entire chapter names. Like we don't even have 10 chapters. Well, maybe we do have 10 chapters. But that's not really what I'm looking for. Just little tidbits of things that we did, 10 of them, and then make connections between them. It does not need to be like a super thorough investigation. Think like if you spend more than 2 hours on it, let me know, and I'll kind of, guide you and put you on the right track, because it should not be taking more than like an hour and a half. I think an hour and a half is probably about the most amount of time that I would expect this to take. So yeah, if you really sit down and you really kind of have an understanding of the topics that we've done so far, it could probably go as fast as like half an hour. Just sitting down, just writing out 10 topics, drawing lines, talking about how they're connected, that kind of thing. Okay. Yeah, there's similarities, how one topic can help you solve a different topic, that kind of thing. Yeah, like you could have, like another one could be, you could have like quadratics, and you could have reciprocal functions. Okay, and they're connected because you can graph the reciprocal Gr11 of a quadratic, right? Like 1 over like x squared plus 1, right? You could graph that, right? And this is the reciprocal of a quadratic. And you could also even throw in like rational expressions into this mix, right? So you could have, there's a connection between reciprocal functions. So I'm going to write RF. Reciprocal functions are rational expressions, right? Like this is a rational expression, right? So just like it doesn't have to be super thorough. You can just choose 10 different ideas that we covered in the class. They don't have to be, quadratics is a huge topic. Like they don't all have to be huge topics like this. Like you could even within like quadratics, you can make connection to being like graphing in vertex form, right? Do you know what I mean? So the idea here is that you're kind of just coming up with a map about how these things are related, how they're connected, and then for the project, you just choose 2 of them. So you go, okay, I want to draw the connection between reciprocal functions and quadratics. I'm going to focus on 2 of these topics and the connection between these topics. Okay, so that's the idea of the project. So we're narrowing it down from 4 topics down to 2, and I'll be updating the rubric and all of that to to go along and to represent these changes within the next day or two. Hopefully this evening, but this evening is looking like I'm not going to have time to do that. So I'll probably end up doing that tomorrow. In any case, I think it is worth saying that I am sorry for another change in this. It brings me no joy to keep changing this, and I hope that you're able to understand that I'm not changing the project because I've changed my mind on something, or that I'm thinking about it in a different way. The reason I'm changing these projects is because, well, we have to, right? So yeah, I'm hoping that you understand where I'm coming from. That these changes are necessities, and it's because we just cannot have a final assessment. So we do have to change the format of this. So that's how that's going down. So yeah, that's the project. I have a few more announcements to make. Now I'm not sure if you've heard this one already, but June 1st. Have you guys heard about June 1st? What's happening on June 1st? Yeah, I'm not sure what's going on in Seven Oaks, but for Winnipeg School Division, so teachers are now going to be back in their classroom. So teachers are returning to class. Yeah. So remote learning continues. Okay, so we're continuing on with remote learning. So it's not like we're going back to school on June 1st. The mark cutoff. Can you just explain that? I'm not sure what you mean by mark cutoff. Just a comment on YouTube. I'll get back to you when you clarify that, because I'm not sure what you mean by mark cutoff. Anyways, yeah. So remote learning is going to continue. We're still going to do these live streams. Come June 1st, I may make a change to our schedule. I'm thinking that as of June 1st, we'll probably do every second day. I haven't confirmed that yet, but I think that so part of the reason why teachers are returning to their classrooms is to invite students for one-on-one conferences. So like if you're struggling and maybe you're at risk of failing the class, this would be an opportunity for you to come down and maybe have a meeting about what we can do to just get some work in so that we can see how you're doing and that kind of thing. So there's a mark cutoff soon. I have not heard of a mark cutoff. But I will look into that. I do not believe there is a mark cutoff, but I'll double check that. I know that report cards are due on June 17th, so certainly that would be like the hard cutoff, because it would be impossible to grade anything after report cards are due. But yeah, our last class, just to give you an idea of some scheduling stuff, so our last class is June 19th. Okay, that's our last class. Yeah, so and report cards are due on the 17th. So our project as it stands now is still due on the 12th. So yeah, but I'll look into that mark cutoff. I'm not sure that I heard anything about it, but here's the thing, there's just so much information that's constantly changing that it's hard to stay on top of everything. It really is. I can't even tell you how many emails I get every day, and all of the emails are just chock full of information. And a lot of the information, I might read it, but then I forget it because something else comes up, and then it's happened a few times where I've been surprised where some of my colleagues know something and they're like, oh yeah, you didn't know about that? It's like, well, I don't know, like I read all the emails, but I guess that must have flown under the radar. And then same with other people too. I mentioned something that I thought everyone knew, and then it's just hard for everyone to be on the same page when the page is constantly turning. So I think that's pretty much all the housekeeping that I had for today. So we talked about June 1st, talked about the final assessment, which is no longer a final assessment, it's just an assignment. Oh yeah, speaking of assignments, there's a new assignment on Google Classroom now. Google Classroom. Yeah, I posted it this morning. It is due Friday. Okay, so it's quite a bit shorter than some of the other assignments that I've given. This is certainly our shortest assignment yet. Let's see how many pages it is, or questions. It's really? Oh, it's still a draft. Oh, geez, I forgot to hit submit. Assign. There it is. Okay. Oops, sorry. I had it all ready to go. It's just I didn't hit submit. So yeah, here, yeah, it's our shortest assignment yet. Let's see, it is 5 questions. So I mean, question 1 has 4 parts to it, like A, B, C, and D. 2 of those questions I'm hoping are fairly straightforward, and then the other 2 are maybe a little more challenging. Question 2 is kind of like a check your understanding kind of a question where I ask you to explain something. Question 3, I ask you to find like the original function where I've shown you the graph of a reciprocal function, and I want to find the original function. So we did an example like that about 2 weeks ago, I think. Question 4, I have a feeling I'm going to get some complaints because it's about electronics and electricity and why on earth would you talk about the real world in math class? Well, this is why we study math in the first place, right? Is so that we can study the world and do things cool like have an iPhone, and you need mathematics for that. So it is an application problem. I'm asking about resistance and power and watts, and I describe the formula to you using words, and I want you to create the formula based on how it's described. So part of that is the reciprocal, so you have to find the reciprocal function. And then I ask, just using that formula that you make in part A, I ask a few questions like, oh, okay, if a circuit uses 500 watts of power and there's 2 amperes as its current, what's the resistance? And if you have your formula, then it's just a plug and play kind of thing. Then the 5th question is using the sine law. So just one question about the sine law. Because we did sort of the trigonometry in kind of like a fast forward kind of a pace, I decided to just have one question on trigonometry. So by the way, we are going to finish trigonometry today. That's what we're going to do today. We'll finish off trigonometry, and then tomorrow we will start the final topic in our class. Can you believe it that this is it? We finally made it. So that's how the cookie crumbles. So let's get to it. Are there any questions about any of this? I just gave you a ton of information. So if you have any questions, now would be a great time to ask. Oh, and I see in YouTube, so it's hard to have these 2 windows open at once. So I'm kind of going back and forth to Discord and YouTube. Yeah, yeah, I don't know why I got all the hate for physics. I mean, like, all the great mathematicians in the world were mathematicians, philosophers, and physicists all at once. They studied many things at the same time. So yeah, that last question on physics, it was just about radicals. It was like, okay, here's a formula, and this formula, like I could give you this exact same formula and just not tell you that it's a formula that's used in physics, and there'd be no complaints. But the moment that you say, oh yeah, there's like gravity or something, like everyone loses their mind. I should make a meme that the old Joker meme, something about everyone loses their mind. I'll make a meme for you guys. Okay, let's get started on the cosine law. So let me pull up this chapter. I think it's 2.4. Is that it? 2.4, I think. 2.4 is the cosine law. Yeah, here it is. So yeah, we're finally here. We made it. We're finishing off trigonometry now. Part of what I'm going to be doing for our report cards and just in general is I'm going to be putting a write-up on some of the topics that we covered and some of the topics that we didn't really have time for. And all the teachers are doing this. It's kind of like a Winnipeg School Division thing, and that's how the Winnipeg School Division is dealing with this, what is it called, learning recovery, or what is it called again? Is it learning recovery? Recovery learning. So part of that is just for the teacher to give a list of topics that as a class, not so much individually, but as a class, what are the topics that we covered, and which covers did we kind of not cover. And one of the topics that one of the topics that we covered that we didn't cover very thoroughly is trigonometry. So I'll be writing that like in our sort of description of the course and what we covered, just so your incoming teacher next year has a better idea, is that trigonometry was really not covered very thoroughly. Yeah, just to give you an idea, because trigonometry, like, this stuff takes time to get an appreciation for. So yeah, just bear that in mind, that we still have a lot to cover in yeah. Okay, sorry, I'm getting distracted. Okay, so let me just show you the cosine law, and I'm just going to tell you what the cosine law is, and we'll do an example or two, and we'll leave it at that, because we're kind of running out of time. I spent about half an hour just now describing non-mathematical stuff. It's incredible how much time it takes just to talk about stuff. Okay, so the cosine law, I'm not going to lie, is one that I have a difficult time memorizing. The sine law, for me, is easy to remember. It's just sine of this angle over the opposite side, right, for all three sides of the triangle. The cosine law, a little more challenging to remember. So let's just write about the cosine law. Okay, so the cosine law is the following. So given a triangle ABC, so given triangle ABC, like so. So I'll just draw a quick little triangle here with vertices A, B, and C, which means that the corresponding sides are lowercase a over here, lowercase b over here, and lowercase c over here. So given triangle ABC, we have the following equations. I'm going to abbreviate equations. So you have this one right here. So we've got c squared is equal to a squared plus b squared. Now you might say, hold on a second, that right there is the Pythagorean theorem. I already know about the Pythagorean theorem. And I know that the Pythagorean theorem deals with, what does it deal with? Well, it deals with right triangles, right? Right angle triangles. Well, this is not the Pythagorean theorem, because this is not a right angle triangle, and I'm not finished writing this formula out. But maybe you can remember that there is some kind of remnants of the Pythagorean theorem. So it's the Pythagorean theorem, but since it's not a right angle triangle, we have to subtract something to AB times the cosine of C. Okay, so that's it. So so basically what the cosine law allows us to do is it allows us to solve for missing sides when we only have partial information, just like it could with the Pythagorean theorem. So let's just do a little thought experiment. So is this consistent with the Pythagorean theorem? Okay, that's a perfectly valid question to have. So is this consistent with the Pythagorean theorem? So let's say that the angle C is equal to 90 degrees. So let's say that we actually have a right angle triangle. So that would look something like this. So now all of a sudden we have a right angle triangle, and here's our right angle. And let's say that this is the angle C, and this is A, and this is B. So this is lowercase c, this is lowercase b, and this is lowercase a. So remember that the cosine law says that c squared is equal to a squared plus b squared minus 2 times ab times the cosine of c. Now the cosine of c, well, let's think about what c is. C is 90 degrees. So let's change this from cosine of c to cosine to 90 degrees. Now let's use our handy dandy calculator and try cosine of 90. So here's cosine of 90 degrees. I don't know if you can see that. I've kind of closed my window so I can't see what I'm doing, but I can see your guys' chats. So hopefully you can read that. It says cosine of 90 is 0, right? It is. Yeah, it's 0. I don't know if you can actually read that, but cosine of 90 is 0. So that means that this is 0. So since we're multiplying it, all of this is 0. So yeah, c squared is equal to a squared plus b squared, which is exactly what the Pythagorean theorem is, right? So the cosine law is consistent with the Pythagorean theorem. So basically what you can think of it as is it's just like the Pythagorean theorem, except it allows this angle over here to be anything. It doesn't have to be 90 degrees. That was the main requirement for the Pythagorean theorem, right? It was that it only worked if this was a 90-degree angle. The cosine law says, well, what if we know a little bit more? What if we know, or a little bit less? What if we don't know that this is 90 degrees, but maybe we know that it's like 80 degrees or 60 degrees or whatever degree that you want. So that's what that's good for. That makes sense? Oh, excuse me, a little bit hiccupy. Okay, so let's do a quick example where we want to know some things. Okay, here we go. Here's a good one. I'm going to copy this from your book, actually. So give me 2 seconds. I'm just going to grab the camera, and here we go. Where is it? Yeah, this is the one that I wanted right here. And what I'll do is I'll zoom in on it. Snap it. There we go. Good enough. A little bit blurry, but that's fine. And then I'll crop it. Example 2. Here we come. Lionsgate Bridge. Okay. Okay, I think this is a great question. Okay, so the Lionsgate Bridge has been a Vancouver landmark since it opened in 1938. It is the longest suspension bridge in Western Canada. Cool. The bridge is strengthened by triangular braces. Suppose one brace has side lengths 14 meters, 19 meters, and 12.2 meters. Determine the measure of the angle opposite the 14-meter side to the nearest degree. And they've got a little photograph of the Lionsgate Bridge that I forgot to include in my little screen capture that looks something like this. So, the bridge kind of goes along like this. Okay, so we've got kind of like like this sort of thing going on. And then each side of the bridge is kind of like attached to this this kind of these trusses, these braces, and we kind of have this kind of thing going on, you know, like whoosh, whoosh. Kind of looks like the Golden Gate Bridge, but it's not the Golden Gate Bridge, obviously, because it's in Canada. So it looks something like that. And then if it was just these two little dinky little rods, then the whole thing would just topple over, right? So so they need to reinforce these with these little triangles here, like this. So this is what they're talking about. And at the bottom here, they've got one that's kind of like this. So here we go. So it looks something like, so they're talking about one of these triangles over here, like this. Okay, so this is what it's going to look like. So we're gonna copy out this triangle, and I'm gonna say that this one is 14 meters, this one over here is 19 meters, and this one was 12.2 meters. Okay, and we are asked to find this angle that is opposite to 14 meters, which is this one right here, right? So I'm gonna call this angle C. Okay. It's like, if you get the opportunity to name your angles here, I think that C is the easy one to find, because remember that we're going to end up finding, oops, not cosine of C, right? Cosine of C. So that's what we're going for. So since that's the angle we're looking for, let's call that C, because that's the cosine that we're going to be taking. So let's go ahead with this. I'm going to punch in the, oh, and I guess what I'll do is, so if that's the angle C, then this is the side C. And then these two, it doesn't really matter which one is which. So I'm going to call this one A. I'm going to call this one B. So remember that the cosine law is that C squared is equal to A squared plus B squared minus 2AB times cosine of C. Awesome. Let's go ahead and start filling some numbers in. So C squared, that's 14 squared, is equal to, well, A squared is going to be 12.2 squared, so 12.2 squared, plus B squared is 19 squared, minus 2 times A times B, so that is 2 times A is 12.2, 12.2, B is 19, and then times the cosine of C, and that's what we're looking for. So just to give you a sense of what we're aiming to do, I'm going to put this in blue, because that's what we want to solve for, okay, is cosine of C. Once we find the cosine of C, then we can take the cosine inverse of that value and get back our angle. So let's go ahead and start punching some calculator stuff in. So I've got 14 squared, so 14 times 14 is 196, right? 196. I think at one point I asked you to memorize that value, but that's fine if you didn't. So 12.2 squared. So this calculator doesn't have a squared button, which is kind of annoying. Exponent 2. Oh, it does have there it is. 12.2 squared is 148.84, and then 19 squared. 19 squared is 361 minus 2. And I'll do this all at once. 2 times 12.2 times 19 is 463.6. 463.6 times cosine of C. So again, that is what we want to solve for. So I'm going to add these two up. So I've got 196 is equal to 148.84 plus 361, that's equal to 509.84 minus 463.6 cosine of C. There we go. Now it's just algebra. So now I'm going to subtract this from both sides. So I guess I should say just this from both sides. So I've got 196 minus 196 minus 509.84. That's equal to negative 313.84, and that's equal to negative 463.6. 463.6 times cosine of c. Okay, we're getting somewhere. Now I'm going to divide both sides by this negative 463.6, negative 463.6, and I get divided by 463.6, and I'm left with negative 0.6683, and that should probably be good. Maybe 313. Okay, and that is, I had to do some rounding, so I'm going to put a dot there. That is approximately equal to cosine of c. So, yeah. Yes, it is positive. Thank you. Thank you. Yeah, because a negative times a negative is absolutely positive. So that's what cosine of c is. So what I can do is, now that I know what cosine of c is, I can find cosine inverse of 0.668313. Cosine inverse of that, that's what c is equal to. So I'm going to do this times -1. Okay, so I've got, this kind of gross value right here, 0.668313. And I'm going to do second, so I hit the second value, right, which gives you the second function, so that when I hit the cosine button, I don't know if you can see that very well. Oh, I know, I'll do that. I'll do it right here. Okay, let me try this again. Where are you, camera? Oh, here you are. Okay. Okay, so I've got this 0.668313, and I'm just going to go back and clear all this. And what I'm going to do is I'm going to go second cosine, so that'll give me cosine inverse of my answer, which is down here. Answer equals 48.062. So C is equal to 48.06, let's say 48.1 degrees. So I had to round there, so rounding there. So C is approximately equal to 48.1 degrees. And that's one way of using the cosine law. Now keep in mind that the cosine law can also be used to solve for missing sides as well. It's not just about the angle. If you don't know any of the angles, then you can use the cosine law to find one of the angles. But there's many ways of using the cosine law. So what I'd like you to do today for your homework is just do question 1. Homework. Question 1 on page 119. So just question 1. You don't have to do a whole bunch. Since we're kind of just fast forwarding through this topic, I just want you to just try a couple of these yourself. Use the cosine law and see how that goes. So we don't have to do a whole ton of work. But yeah. And then I guess for the exit slip today, I thought I had a good question for you. I forget. Okay. Yeah, so exit slip, we're just going to do, I don't know, just say hi to Goose. She's retiring from her teaching career now that I'm going back to school in June. So this is her last week. So she's only got one more week of teaching left. So we're gonna have to say goodbye. She's the best teacher's assistant that I've ever had. Pretty incredible stuff. Yes, she will. Okay, so I'm gonna go, and I will talk to you guys tomorrow. Let me know if you have any concerns about the project or any of the assignments or anything like that. And until then, hope you have a good day, and bye-bye. Okay, and bye-bye, YouTube. Oh, shoot, how do I do this? Sorry, YouTube, I still have to open this window. There you are. I gotta click this button, open the stream, and end stream. Okay, bye-bye.